Hello. So we are starting kind of like our third unit, Unit 2B, where it's really an introduction to linear patterns and linear functions. So we're going to start off with lesson 9.1 for this unit, which is on slope, which is a key part of a linear function and a linear pattern. So we're going to do 9.1. This is in the consumable on page 123. So we today are going to be able to determine the slope of a line from a graph, and we're going to be able to develop and use the formula for slope. So let's first talk about what is slope. So Margot's grandparents are moving in with her family. The family needs to make it easier for her grandparents to get in and out of the house. Margot has researched the specifications for building stairs and wheelchair ramps. She found the government website that gives the Americans with Disabilities Act, ADA, accessibility guidelines for wheelchair ramps and discovered the following diagram. So then Margot decided to look for the requirements for building stairs and found the following diagram. We look over here, it says connect to social science. The table gives information from the ADA website about the slope of the wheelchair ramps. Oops, didn't mean to draw on that. So the slope, the incline of the ramp or the decline of the ramp has to be within a certain parameter. So the slope needs to be greater than 1/16th and then less than or equal to 1/12. And that would be the same for our decline. So it says, review with your group the background information that is given as following items. So obviously, I'm your group. So number 1, what do you think is meant by the terms rise and run in this context? So if we're looking at this, we see we have a rise and then a horizontal projection or a run. And again, we still have the rise and the run. So it looks like the rise is equal to our vertical movement. So how much do we go up and down? Vertical movement. And the run is equal to our horizontal. How much do we go left and right? When we think about slope, we're really thinking about how steep something is. So for our wheelchair ramp, we don't want it to be super steep. We want it to have a flatter incline. So then it says, consider the line in the graph below. So vertical change can be represented by the change in y. And we can see that because my vertical change is how are my y values changing? How much do I need to go up or down? So that's my vertical change, my change in y. And then my run is represented by my horizontal change, which is my change in x. So how much do we need to go left and right? So it says vertical change can be represented as change in y, and horizontal change can be represented as change in x. So it's the vertical change between points A and B. So from left, and we always want to go left to right. So from left to right, how much do we need to go up? We're going up to get to B. So we would need to go up 1, 2, 3 units. So 3 units. Then it says, what about between points A and C? So that's between this point and this point. So I need to go up further, an additional 1, 2, 3 units. So that'd be a total of 6 units. Then it says between C and D. So that'd be from this point to this point, and I need to go up 1, 2, 3. So 3 units. Then it says, what's the horizontal change between points A and B? So horizontal, so I'm already up 3, so I need to go to the right. And I would need to go to the right 1, 2, 3, 4 spaces. And then between A and C, so again, I'm up. And then I would need to go over 1, 2, 3, 4, 5, 6, 7, 8. Oops. And then C and D. Well, I'm already up, and I would need to go over 1, 2, 3, 4. Perfect. So over here it says, slope is the measure of the amount of decline or incline of a line. The variable m is often used to represent slope. So the ratio of the vertical change to the horizontal change actually gives us the slope of the line. It tells us how steep it is. So my slope, and making sure that this is, if it's not already, we did this in Zoom, but if it's not already, this needs to be written out in our math notebook. My slope is going to equal my vertical change over my horizontal change. That's my ratio, vertical change to horizontal change, which we also call change in y or over change in x, or delta y over delta x, but delta just means change in, or we can also say rise over run, because rise is my change in y and run is my change of x. So it's my vertical change, my change in y over my change in x. So it says find the slope of the segment of the line connecting A to B. So vertical to horizontal, so that would be 3 to 4. A to C, well, we had vertical to horizontal, so that would be 6 to 8. And then C to D, well, that was vertical to horizontal, so that would be 3 to 4. One thing that we always want to write when we're writing our slope is we want to make sure that we want to keep it as a fraction. So if it's improper, leave it improper, but we also want to simplify it. So 6/8 also simplifies to 3/4. So 5 says, what do you notice about the slopes of the line in 4A, 4B, and 4C? Well, they're all the same. The slopes are the same. So what does your answer in item 5 indicate about points on the line? Well, if I'm talking about points on the line, the slope between any two, wrong two. The slope between any 2 points on a line is always the same. You can think about that. If your slope's different, you're not going to have a straight line, because it'd be like you have the slope and then it changes. That wouldn't be a straight line. When we're talking about a line, it needs to be straight. All right, so it says slope is sometimes referred to as rise over run. Explain how the ratio rise over run relates to the ratios for finding the slope mentioned. Well, remember that rise was my vertical, which is my change in y. And run is my horizontal, which is my change in x. So rise over run, change of y over change of x. So it's the same thing. So it says, reason quantitatively, would the slope change if we counted the run before we counted the rise? No, we could count the run before we counted the rise, but as long as you do change of the vertical change over the horizontal change, it won't change your slope. So 9 says, determine the slope of the line graph below. So really, we just need to find the rise over run. Now, the key main point, it says select 2 points. Make sure you're selecting 2 nice points with nice ordered pairs, so integer ordered pairs. So I see this is a nice point. This is a nice point. And this is a nice point. So when I'm doing this, now I can use any of these points to do my rise over run. Let's just do the first 2 points I picked. So my rise between, let's name this A and B. My rise to get to B, I go up 3. And then my run to get to B, go 7 spaces. So my slope is 3, 7. So that's how we find the slope given a graph. However, we're not always going to be given a graph. But I'm going to stop the video here and make a part 2.